Okay, test on Monday. Today we'll take a look at what you should expect. This test is kind of over a few different chapters in the Think Well material. Chapter 4, Chapter 5, Chapter 6, and then the first section out of Chapter 7. Of course, Chapter 6 was very short, and then just the one section out of Chapter 7. Not a lot from there either, but the bulk of it is going to be Chapter 4 and 5, and guess what? You're going to be taking derivatives of a whole bunch of different functions. Chapter 4 was mainly the basic operations, the basic derivative rules, shortcuts, however you want to call it. We've got the power rule. We've got the product rule, quotient rule, and then the chain rule. And as we kind of work towards more difficult stuff, a lot of them were one rule within another rule, or 5 or 6. As far as the difficulty on the test, I'm not going to put something insanely difficult like some of the ones on the worksheets were. I would agree with you, insanely difficult, but there might be 2 or 3 rules to work through rather than like one of those had like 6 chain rules inside each other. I won't quite go that bad, but maybe just 2 or 3. Those were the basic rules, and then Chapter 5 we looked at some specific types of functions and their derivatives, trig functions, exponential, and the logarithm. Now, both the exponential and the logarithmic functions, for the test, I will limit that to just the base e. So e to a power or the natural logarithm. I won't throw any other different bases at you. Later on, we may see some different bases, but for now, just the natural log and the base e for the exponential. Let's see. So I think that was all of the different types of functions, and then we saw a couple different worksheets with some combinations, the derivative rules, and then after we got through the log functions, we had some combination of derivatives. Now, some of the problems that you had the most difficulty with were, or at least some of you, were simplifying algebraically, then doing the derivative. And some of that also included the log properties. Do as much simplifying as you can before you take the derivative. That makes the derivative that much easier. Okay. So, and in Chapter 6, we looked at implicit differentiation. Yeah, that one's a little different. Differentiation. That's a big word, too. Big word for me as a mathematician.
That's why you said it.
Yeah, that's why we make up these nice little short symbols to represent these huge words. But implicit differentiation, finding dy by dx, or in some cases, especially with different letters, t and s, maybe find ds by dt, or even dt by ds, or r and h, find dr by dh, or even with dy by, or y and x, find dx by dy. So notation-wise, you got to recognize what we're taking the derivative with respect to, and in that case, dx by dy, we would take the derivative with respect to y. So derivative of x in that case would be dx by dy, but the derivative of y in that case would just be 1. So make sure you're reading carefully how the problem's worded. Now, with the implicit differentiation, we also looked at a few applications. What does the dy by dx mean? Slope of the tangent line. Or equation of the tangent line. Maybe I'll ask more than just what's the slope, but what's the equation. So you need to know how to find the equation of the line. The slope of that line would be the derivative, the value of that derivative at the point. And let's see. Yes, that was pretty much all we did on implicit differentiation. And then finally the 7.1, the worksheet there, finding velocity and acceleration, and then applying it to object in motion. So that's kind of just the overview of the test, and we'll look at some specific problems. But for the test, there will be 20 problems. A majority of them will be find the derivative of this function, whether it's just a simple power rule or logarithm or trig function. Make sure you know all 6 of your trig function derivatives, or any of the combinations, those types of rules and those particular types of functions. So probably 12, 13, 14 of the problems will be simply find the derivative of. And then some of the applications or other types of problems will fill in the rest of the test with those. Find the value of a derivative, which again would be find the slope of the tangent line at a particular point. Implicit differentiation, find dy by dx, find dx by dy, find dr by dh, whatever combination of variables we have. Equation of the tangent line, we looked at several of those as well, and then your velocity, acceleration, those motion type problems from the last part. Okay, so any particular problems that you want to look at? Okay, an equation of a tangent line. For this particular graph, this is actually number 8 on the applying implicit differentiation worksheet. But usually, well, this is most likely to cause the most amount of trouble finding that derivative. So, but implicit differentiation, we take the derivative. Now, where we're talking about the tangent line, we want the slope, which is dy by dx. So take the derivative of both sides with respect to the x. Okay. And as we look at each part, well, this part, derivative of x cubed would be what?
3x
Okay. Now, I'm going to write this middle term out a little bit more to kind of give you an idea. When students make mistakes on these, it's usually they're trying to do too many steps in their head and they lose, especially this little thing right here. So we will say plus the derivative of negative xy, and then we'll kind of work step by step through that. And then, well, let's do the same here with y squared. Now, hopefully this one's easy enough. What would that be? Okay, derivative of a constant is 0, no matter what we're taking it with respect to. So, well, let's work on this one. Derivative of y squared with respect to x would be what?
2y and dy.
Okay. Sounds like most of you got that one figured out pretty well. And, okay. So this one, what are we going to need to do to find the derivative of that term? Okay, product rule. Now, you may want to kind of think of it as negative x as your first and y as your second. Some of you may just leave the negative out here. That's okay, but a lot of times that's where problems show up, is you forget to distribute that negative through the parentheses, or, oh, I didn't want to do that. My eraser's a little big. There we go. Okay, so product rule. We will have the first times the derivative of the second, which would be what? Then plus the second times the derivative of the first, which would be what? Okay, -1. And then we have plus there. Okay. So that form, once you have kind of the idea of what's happening, that's not too bad. Here in a little bit we'll kind of expand, look at some maybe x cubed minus, or x cubed times y squared and what that would be. But from here, next step, we would need to solve for our dy by dx, and well, we could move the constant terms, well, constant, I mean the non-dy by dx terms, to the other side. So add y and subtract 3x squared. We'd have a positive y minus 3x squared, and then factoring out the dy by dx, to find dy by dx, we would divide then by that binomial. Okay, top of the next page we'll do that, and we also need to remember we're looking at this point, so -1, 2. So our dy by dx then will equal what? Y minus 3x squared divided by, what was that, -x plus 2y. Or, again, if you want to rearrange order, 2y minus x on the bottom. A lot of times, especially in textbooks, they like to put the positive terms first. Doesn't really matter, you get the same answer either way. Now, this would be dy by dx, and to find the slope, of the tangent line at that particular point, we need to plug in -1 for x and 2 for y. So let's see, we'd have -1 over 5. Okay, so there's our slope, and again through the point -1, 2, so point slope form, y minus 2 equals slope times x minus a -1. Well, that'll be +1. And from here, I mean, this is fine to leave it there. Some of you would solve for y, which is fine as well. Add 2, we'd have 1 4/5, which would be, what, 9/5. So. Plus 9/5. So there, or even here, either one of those. I'm not going to be real picky about the answer form. But that's finding the equation of the tangent line. Of course, the bulk of the work is your implicit differentiation. Questions on that part? Well, let's kind of step it up a notch with the form. We'll find dy by dx implicit with let's do that one. Okay. Several things to keep track of here. Well, finding dy by dx, well, our first term will just be 2x. But now the next term, once again, we'll have a product rule. So we'll have the first times the derivative of the second, which would be what?
2y dy dx.
Okay. Plus the second times derivative of the first in terms of x. It makes it a little easier. And then we have our next term, again, a product rule. That little dashed line out in front can cause problems. Don't lose that negative. So what I'm going to do is, again, go ahead and put it as plus, and then we'll think of it as -x as the first and y cubed as the second. So the first times derivative of the second plus the second times derivative of the first, which is just -1. Okay. And then, well, at least I was nice enough to put a constant on the other side, so derivative of 4 is 0.
Are we going to have to do implicit differentiations of, like, anything with pi?
Possibly. Derivatives, implicit derivatives, anything with pi, you got to remember pi is nothing more than a number, just like 2. If you want to replace pi with 3.14, just to kind of get your mind thinking constant number, go ahead and do that. And then at the end, anywhere you have 3.14, replace back with pi. But yeah, the pi could show up on any of those derivative problems. Okay. Now to solve for dy by dx, again we have to kind of look at what term terms have the dy by dx. Everything else needs to be moved to the other side. And it looks like we'll add y cubed and then subtract these other two terms. So plus y cubed minus 2x minus 3x squared y squared. Okay. And then our dy by dx terms. We can go ahead and factor out the dy by dx. And let's see, we'd have 2x cubed y minus 3xy squared. And finally divide by our binomial. Dy by dx then will be y cubed minus 2x minus 3x squared y squared all over 2x cubed y minus 3xy squared.
Are we finding the slope in the tangent line?
In this case, I was just going to find the derivative, find dy by dx. Now, to find the slope, then we take our point and plug in x value and y value. The last point we looked at was -1, 2. So slope of the tangent line, you plug in -1 for x and 2 for y. So, okay, questions? Any other particular problems that we want to look at? Okay, we'll do an implicit with natural log. And, well, sometimes it's easier to rewrite your natural logs using the algebra properties. In this case, this side, because it's a minus, we're not going to be able to do anything to the left side of the equation. But this part, we could at least separate a little bit. Let's go ahead and look at what that would be before we do the derivative. Now, we have the minus out in front, so we've got to watch that as well. Natural log of x times y, what can we do with that?
ln x plus ln y.
Okay, when we're multiplying inside a logarithm, we can separate by adding the log of one plus the log of the other. And then, of course, we still have the minus there, and we'll take care of that minus as we go through the derivative. Next step. Okay. So, derivative of this with respect to x. Okay. Derivative of the logarithm is 1 over the inside. Then times the derivative of the inside. Well, make things a little easier. Derivative of the 4 is 0. So we're really focusing on derivative of x cubed y squared. And that will be a product. So we've got to make sure we multiply that whole thing by the fraction out in front of it. So x cubed times derivative of y squared would be 2y dy by dx. And plus derivative of the first times the second. Okay. That would be the derivative of our natural log on the left side of the equation. Questions on that part of it? Probably the biggest problem with this is the algebra after we've done the derivative. Okay. Next we have derivative of x times y. So first times the derivative of the second plus the second times the derivative of the first, which is just 1. And now, let's not forget about the negative, but let's go ahead and take the derivative of our natural log parts minus derivative of ln x. That will just be 1 over x. And then minus derivative of natural log of y would be what?
ln of 1 over y and dy dx.
Okay. 1 over the inside times the derivative of the inside, so derivative of y with respect to x. Okay. And that's the last of the right side of the equation. Now, at this point, we've got to solve for dy by dx, and we got 3 different terms with dy by dx in them. This term, though, we need to remember is multiplied by this fraction. Various ways of going through simplifying here. What I would probably do is just go ahead and multiply the fraction through these parentheses. And let's see, we'd have, along with kind of cleaning up the notation, we'd have 2x cubed y over x cubed y squared minus 4 times our dy by dx. Then plus 3x squared y squared all over the x cubed y squared minus 4. Okay.
Could you put all those over x cubed y squared minus 4? Like,
Right. We could put all of this over this denominator as well. Again, at this point, this is a fairly complex algebraic equation. Lots of different ways to solve for your dy by dx. So whichever way works best for you. And then the other side, let's see, we got the x dy by dx plus y minus 1 over x minus 1 over y dy by dx. Now, kind of looking at what we have, where we're heading with it, we need to solve for dy by dx. So all 3 of those terms need to be on one side. The other terms need to be on the other side. Again, lots and lots of ways to do this, but let's go ahead and subtract this and add this, getting our dy by dx over here. And we'll have to do that on the next page, I'm afraid. Okay, so getting our dy by dx's all on one side, we'd have to subtract the x dy by dx, add the 1 over y dy by dx, and then we still have this term to subtract on the other side. We'll go ahead and factor out the dy by dx as well. And this is going to be kind of a ugly answer. Again, depending on which direction you go, depending on what algebra you do, you may have something slightly different than this. As long as it's a correct form, I will accept it. You don't have to have it exactly like mine, but okay, so we'd be subtracting this term. Okay, and then finally, what makes it really ugly is we'll be dividing this on both sides. So dy by dx would equal y minus 1 over x minus 3x squared y squared over x cubed y squared minus 4, and then all of that over this nice little expression.
Did you take the answer there, or would you want us to keep simplifying?
Get to this point and stop. This would be plenty good enough.
But the next step that you could do is Okay.
Yeah. Now, back a step from here, we could have multiplied both sides of the equation by the least common denominator. I guess it'd be that and then the y. Multiply that on both sides, and that would get rid of the fractions. So when we get to this point, then we would then only have a simple fraction.
Simpler.
Yeah, not so difficult fraction. There we go. Instead of what we call a complex fraction with a fraction within a fraction. But algebraically, it gets really, really messy. I'm not going to worry too much about your algebra skills. I want to know, did you learn the calculus? Okay. Any other questions? Okay. One of these, find the points on this particular curve where the slope of the tangent line is -1. Again, most of the work is finding dy by dx, and then, of course, from there, the algebra involved. So dy by dx, this part, find your product rule. So the first times the derivative of the second plus the second times the derivative of the first, which is just 1. And derivative of x is just 1. Derivative of 4 is 0. Okay. So we want the slope to be -1, so we can solve for the dy by dx. We can add 1 and subtract y squared. Kind of get a expression like that. Dy by dx then would be 1 minus y squared over 2xy. And this is to equal -1. Okay. So what we're going to end up with, and this will turn out to be a little uglier than what I would normally give you. Trying to make up a problem doesn't work in some cases, but what we can do here, multiply both sides by the 2xy, gets rid of the fraction. And then from here, yeah, it's going to be quite difficult to solve. If a problem like this occurs, you'll end up with a lot easier equation than what we have here. But essentially what happens, you've got this one equation that comes from our derivative set equal to the particular value, and then it also needs to be on this graph. So it turns out essentially 2 equations, 2 unknowns solve this system of equations. And yeah, it'll be a lot easier algebraically, but that's the idea. Once you get the derivative and set equal to what it is, you'll end up with 2 equations and 2 unknowns.
Okay.
All right.
At it and